All right, cool. Thanks for that you find the time to join us today. I know it's always a little bit like, too early, too late. The time is never the right one, but it's great that you make it here, and it's great that you make it here for the Cloud Native Sustainability Week. It has a super awkward long title, but somehow we need to put all the organizations into one thing. My name is Max Körbecher. I'm your host for today from Reply, from Liquid Reply. But actually, my role is more today on the one hand side, CNCF ambassador, and on the other hand side, I'm also the co-chair of the CNCF Technical Advisory Group for Environmental Sustainability. So I'm very happy to host one of at least the 3 events which are going to happen today. And this is kind of interesting what's going on, because the Cloud Native Sustainability Week means really we have 21 events from North America to South America, around Europe, India, China, and also Australia, which is an immense community effort. So it's like huge amount of preparation going on in all kind of different locations. Multiple ones happens here in Germany, but also in all our neighbor countries, which is very fantastic to see this whole thing come to life and being organized. And a special thanks also to the organizers behind it, who prepare all the slides, who prepare all the communication, organize it with the CNCF Foundation to give a little bit more marketing boost. That's a very, very big and great effort. So the basic facts I gave you already. On our blog, you will find also every day a blog post coming up about different topics, about different tools, giving you a little bit more introduction. You can find it under sustainability.cncf.io. And we're also going to have a virtual mini conference later this week where everyone can join. This will be also like with a few lightning talks, a few more incubation about the Sustainability Week and what's going on around IT sustainability in the open source and in the cloud native user space. There's also for some of the locations happening a daily live stream. Today is not a daily live stream, no worries, but we were going to record it. So if you do not like to be recorded or whatsoever, at the moment you just record it from behind. But if you really do not like it, just let me know and then we can blur you out later. About the CNCF Technical Advisory Group, I know again it's a very, very long title, but what we are doing is to help the cloud native tools in the open source space who have a focus, or maybe have a focus on optimizing the power consumption and optimizing the systems, maybe in measuring it, and to give them a proper idea how they can get better, how they can get a little bit more footprint. We help them to grow, or we also recently started a little project to help them to measure themselves so that they are aware of their own footprint, and also as an open source project can compel them per release how maybe to get a little bit more efficient over time. This in short. We have a big chapter, read it. We have a GitHub repository and a website where you can find more information about that. So some of our projects, the dark green ones are already live. So we have a little landscape brought together, giving you little guidance, like which tools are out there in the CNCF landscape. Because I mean, if you go to landscape.cncf.io, it's like, it feels like 500,000 tools just like jumping into your face. A little bit difficult to find around. So we practically wrote the landscape together, give a little bit more context behind it. So that you know, okay, these are the 3, 4, 5 tools which I can utilize for the measure part. These are the few tools which I can utilize to take care about application deployment and so on and so forth. We have also very active community advocacy and outreach. So the thing is, when you take a look into the open source space, there's a couple of foundations which take care about sustainability. There's the OS Climate, there's the Green Software Foundation, there's an LF Energy, which takes care more about the real electric grid and how to use open source in this space. But all of them somehow play together, right? And so also we have a big part in this role. And to ensure that we all communicate in the same way and have the same ideas, we need a community outreach. We need to get in touch with all these foundations. There's also foundations which are not part of the Linux Foundation, where we also try to keep a contact and work together, because it doesn't make sense if we reinvent the wheel for some stuff like maybe some of you know the SEI specification, the software carbon intensity specification. A few months back, we thought about, okay, we need a framework to describe the power consumption of a tool, but it doesn't make sense to reinvent the wheel, so we use what is there already. Recently started is also the CNCF Green Projects Reviews. This project has as a key central deliverable to help all the open source projects to measure themselves. In a first step, to understand per release how high is their software carbon intensity. It's not about that to have actual value, because the development is distributed around the globe. It happens in various different data centers, so it's kind of difficult to get this in the first step done, but to find a reference value against which they can start optimizing, right? And then in the future step, we want to take care about, okay, how we can do and optimize the whole software development lifecycle and get there some reduction into it. For some projects where you maybe have like 20, 30 developers, it doesn't seem like a big thing. Thinking back about very big projects like Kubernetes, where you have several thousand developers around the globe continuously testing, several hundred test clusters, several thousand tests continuously running, change just a little bit of this will have quite a big impact, at least for the single project. And then we have two other projects currently in the make. We have the majority model, which is currently more like a thought construct to have also a little bit more high-level decision takers to have like a reference to think like, oh, how far we have considered sustainability in our IT strategy right now. And on the other hand side, we have the Kubernetes sustainability deep dive. It's more about the guidance on how with Kubernetes, on Kubernetes, and around Kubernetes, I really can optimize, right? It's more like the operationalization of the landscape document, which we have written, like best practices, you could call it. If you're interested, feel free to join us, because we're always searching for some helping hands. And yeah, there's more ideas to come up in the future where we need people. I'm faster than the slides as usual. If you want to get in touch with us in the CNCF Slack, we have also our own space with a technical advisory group for environmental sustainability. And yes, it has a stupid name because it's too long otherwise with environmental sustainability. You can also find us on the website or in our GitHub repository, where you can also find current recent developments and things which we are working on. Always feel free to comment under it, give your ideas, give your thoughts to it. Maybe if you've made your own first integrations, your first experience, and would like to share it, it's always a good place to get started with us. As said, this week we also will have this mini conference on Thursday at the 12th of October. You can find it also within the URL from the community. Feel free to join. It's a little few hours long mini conference, short, fast paced, so it's not too much overload and more like giving you some thoughts and incubation about further ideas in the future. For today, very important, make a picture. I know it's a little bit early to show the QR code, but later on, we're very happy if you give us some feedback. We're very happy to receive your feedback to also improve maybe this for the next year. Hopefully we can make it then even bigger and even more well-known. And you maybe can even get a gift code out of this, which allows you to do some Kubernetes certification, for example. And with that, we can jump right into what's going on today. The introduction part I did already, so we will move on right to Antonio, who'll give us a short guide to valuable tools in the sustainability area. Then I'm very happy to have the people from Amadeus over. As I learned, it's not only Fritz, but the colleagues will also introduce themselves later, and then I will add you on the slide when we upload it. They will share us a little bit from their research and experience, so I'm very excited because it's an end user use case and not just like, hey, it's a product or whatsoever. Super cool. And last but not least, we will have an open discussion round. So we will have a short break, rearrange a little bit the chairs, and then just throw thoughts at each other and see where we're going to. With that, Antonio, stage is yours.
Yeah, welcome everybody. This is a little catch up on the green tools that are out there. And yeah, the agenda for today is like understanding a little bit what is sustainability in IT, what should we do in our context, and then we'll talk about Kepler, which is a tool I know a little bit better, and also other tool within this landscape. A little presentation. Who am I? I'm a senior consultant at Data Reply, and I'm a tech lead working with a telecommunication customer. I'm a cloud native enthusiast, and lately I'm discovering the CNCF world, which means that I'm getting started in the as a contributor in the tag environmental sustainability, and I'm also getting started in the as a mentee in the Kepler project. So my story as a last joiner in the tag started at the last KubeCon, which was in Amsterdam, was a very amazing event. And during a keynote, I realized that one of the projects that were presented and were actually presented from Azure were similar to something that I was doing in my master thesis. And that's where I got these boost bumps, and then I said like, wow, we were on the right track. If we only were Azure, then we could have developed something nice. And I wish there was a community that was not there at the moment. So I spoke to the people and I said, like, literally the community was not there in 2019. It founded like the tag founded almost like 1 year ago. And it would have been so nice to have someone to talk to, a community to back up with ideas and to confront with people. I've been reached out from some students. It was very nice. And yeah, so I said, why not joining open source? Why not getting, like, everybody we use open source code every day, so it's time to give back a bit. So what does it mean to be sustainable in the cloud native? So this is a little draw that I tried to do like for what we do every day. So there is one team which writes code, getting tickets done, and then there is a little monsters, right? Like that is like involves cloud services, infrastructure as a software, Kubernetes, different environments, microservices, and somehow produces some CO2, right? And the problem is that we don't know what is the relationship within what we do and how this CO2 is produced. And this is a big problem because, yeah, like the relationship is complex. There are many layers, and we're gonna get deeper into that. So sustainability as a first point comes very late. So we have a problem. So, and usually we want to solve this problem with software. Then we design a solution, we implement this solution, and we test this solution. We have multiple iteration between 0.2 and 0.5. And at some point, like we're gonna question ourselves, like how we want to optimize our solution for being more sustainable. So how do we get there, right? Can we design, like a question that popped into my mind is like, can we design a solution to be sustainable first, right? So are there some principles to sustain a green solution? And there are more and more academic publications that are being published. There are some books, some podcasts, but still, at least to my humble point of view, there are like some unstructured information, many inputs, many ideas, but there is no one set of rules, no one framework, and everybody's talking about it. This is very good. At least like we are going into that direction, but maybe the path is still a bit longer. And there is like, those are some of the sources I personally follow. And I don't know, there are some podcasts from the Green Software Foundation, Environment Variables, Green.io, a nice book that has been recently published. And these are, yeah, some of the sources which also you can maybe follow. And why is it so complex? This is also a question I had. There is like all the discussion between scope 1, scope 2, scope 3. Some people says like if we move data in the data center, then like what is the water utilization, what is CO2 carbon footprint? It's a very tough discussion, and maybe there is a lack of clear maturity model. There are multiple tech layers. This is true, and different interaction with cloud providers. We're gonna go deeper in each of these points, and yeah, so this is one of the models in which we can analyze what kind of carbon footprints emission we have. There is scope 1, that is like usually the direct scope. So if we drive a car, the amount of oil we burn to drive the car, this is the direct scope. In software, there is usually no or very little direct scope. And then there is scope 2, so like the electricity we need for running our servers. And there is scope 3, which is actually usually the most big part. So it's the embodied carbon. Also here, I've read some discussion like, should we consider scope 3 in our tool chain, or should we not? Because scope 3 should be actually taken by software or mainly hardware producers. And like still discussion is going on, and but this is a big picture of what we can consider. And we are doing some steps in having a maturity model. I think Max proposed a really nice idea, which is still an issue on our tag. So there are some steps we can assess our work to find out where are we in our path to a green, more sustainable software. So the first step being a blind optimization. So you know that there is a component of your software, of your data platform that is inefficient. So maybe you do load of Docker images 20 times a day. Maybe you can do only once at the end of the day if you deploy a lot, right? Like this is like blind optimization. You know already that something is inefficient. You do something to reduce this footprint, and then you slowly have some metrics. So you have some carbon report that you have, and with the help of these metrics, you realize that there are some hidden spots that you maybe can get better. And then next step would be to automate those decisions. So you realize that an application is using, maybe a node is very little utilized. We can get rid of a node within a Kubernetes cluster, and this can be shown by metrics, and we can take automated decision. And so on and so on. Then the maturity model can grow and can be diversified. So it's true we have multiple layers here. I've tried to quickly draw what are the different carbon emissions and why are, like, I've tried to do a little schema of the landscape document. So it's complex because there are multiple hardware to take into account. Each of hardware can be a different generation, architecture, vendors. And then on top of that, we have different containerization layers, virtualization, missing data, different kind of workloads. So it's not an easy landscape to organize. If you take a look to the to this document that the tag has produced, there are a lot of points, and each of them as maybe a tool or two to understand what you can do to assess the different layers of your architecture. So yeah, it's not an easy, it's not the easiest thing to do, right? Like, because we have two objective functions. One is to have good code, and also the other one is to have good code which produces little carbon footprint. So it might take a while, and but we still should understand what we can do in this context. And I think it's important to draw a line between like what we can do and what we cannot. And I think AWS, like, for example, tried to do so with a responsible sustainability model for the cloud. So there are some things we cannot control, and there are some things as developers, as Kubernetes administrators, we could control, right? So yeah, like, AWS should be responsible for all the complex part, which is related to cooling, water. It's true that we can also influence how much the cooling and the water and the energy can be used by shifting data. There are some people that say that shifting, like basically the follow the sun model, you can shift a lot around workloads during the time of the day where like the energy is more green. But like, those approach also have some problems, right? Like, for example, if I have some data set that carries a lot of data within the project itself, is it gonna be like green to move a lot of data around? So like, if I have to move terabytes of data from like a point A to point B, still some questions are open, and that's why like basically cut myself with this question. So like, what can we do within our Kubernetes cluster, right? Like there is my scope. So I don't get lost, I can keep things easier. And maybe I don't focus as a first step to what is the carbon footprint, but I really focus on like, how can I reduce the electricity usage of my Kubernetes cluster? So step one is to measure, because without measuring, we don't know, we can only blind guess, as the maturity model highlighted. And one of the most interesting projects for measuring energy utilization in the Kubernetes cluster is Kepler. That's why I joined this project also as a contributor. I'm trying to understand more and more how it works. But yeah, in few words, what is Kepler? Is a Kubernetes-based efficient power level exporter. So for every container that you have in your Kubernetes cluster, it tries to assess how much electricity it's using at the given moment. So it's a project that has been created between a partnership with, of Red Hat and IBM, and it's been donated to the CNCF as a sandbox project. So how does Kepler provide metrics around the energy of your containers? It aggregates some energy metrics from REPL. There are some technology that takes the information directly from the hardware. It's some Intel library. And it has estimation model in the case of which, like, for example, in a virtual machine, you cannot access REPL metrics because the hypervisor is hiding these metrics, right? Because you might have metrics that are for a single hardware, but are shared between different tenants. And exposing this information can be a problem. So they just don't let you see what's the REPL metrics. And in those cases, there are some pre-trained model that have been used and that can tell you what is the energy utilization of a container. And it uses also eBPF. Then there is a typo here. It's not eBPF, but maybe only I have recognized. And that attributes power metrics to pods and exposes this data to a Prometheus metrics so that you can visualize it in a nice Grafana dashboard. And there are some challenges. So one I already talked about. So there is no REPL access directly into VMs. So we're using data for assessing our energy metrics, which are very synthetic, right? Like they're generated by ML models, and we still have to test if this is a right approach, so how it correlates with the real energy utilization. And there is a security issue, which is this platypus attack. It's very complex. I'm not an expert in security myself, but what I understood is that by sharing the energy consumption utilization, you can infer the cryptographic keys. So this is for sure a problem that they're working on. And also there are challenges related to eBPF. So it's a new technology. You need to load some programs directly into kernel module. And this might be a problem when you have multiple eBPF technologies. So this is also something that could cause problems. And you have to load the Linux kernel header in some of the nodes. So what I'm working on, I'm verifying like Kepler installation and utilization in AWS and Azure. So those are the issues that are open, and we are currently testing. So it seems, for example, that in VMs there are some problems with the metrics, so it doesn't recognize so well what different containers. And it might be like we're still discussing with the founders of the project why is that. So it's still very open, still very much ongoing. And we have decided also to use Kepler as a tool in the Greenview working group of the tag, which was what Max talked about. So we're trying to assess how green a given CNCF project is, and we are trying to assess this in different release, and we'll be using Kepler as well. And more on Kepler, there is a software, Green Software Foundation ticket, which is like trying to let the different cloud providers agree of Kepler as a standard. for measuring energy metrics within the cloud native space. Other tools that are that I would like to present you today, but I don't know so well in detail, so we're just gonna quick run over them. It's Scaphander, which is basically the same of Kepler, so it's still measuring energy metrics, but on VMs mainly, while Kepler works on any Kubernetes environment. Also, yeah, like it goes down into containers, while Scaphander works like of the energy metrics of the VM itself. So it's a different level. And then we have a carbon-aware Kera operator, which is a nice scheduler. We will talk about it in a minute. The scheduler that is not often cited as a green tool, but I think it can happen in this. It can help in this direction. Carpenter, WebAssembly, and then in the end some green scraper that could help you understand like what are the hot topics in latest in the latest KubeCons about the green stuff. So this is how Scaphander looks like. Also, Kepler would look very much the same. So we have Grafana dashboard that is trying to tell you what is the power consumption and all that you might be interested in. And so like we can see data about energy consumption and how it behaves. Then we have the carbon-aware Kera operator. This is a scheduler that tries to schedule a given load on a given region, which is aware of the carbon footprint of the region. So like if you have the choice of where to place your pod, you can the carbon-aware scheduler will try to schedule it in the region which is more clean. So it has this notion of awareness of what energy is being used by your nodes. The scheduler is something we use in production, which helps you understand like what nodes are under or overutilized, and this can also help you kill some pods in an automatic fashion. And this paired up with an autoscaler can help you decrease the number of nodes that you run in your runtime. And there are different scheduling decisions that can be chosen, and this can be an helpful way to reduce the number of unneeded loads in the cluster. And then there is WebAssembly. I don't know this one really well myself, so I've been presented at KubeCon the first time. At least to me, I have attended a tutorial, but basically what I understood is that there is a virtual machine that is executing in very efficient and fast way pieces of code that should go into web-based application. And it has a sandbox, it has very small footprint, and it's very, very efficient. And then, yeah, in the end, there is this green scraper. It's just a tool that check all the talks that have been done at a given conference, and will give you all the latest details about green software deployments and developments. Yeah, then last but not least, I think this is a nice starting point. If this is a free certification, if you're interested in like green software, can be a nice base. And yeah, I still need to take this one, but I think it was worth to share. And yeah, that's all. Questions? Yes. Yes, it's written Go. But then like it has this model, like machine learning models for energy consumption, but the main application is written in Go. Yes.
I have actually like two questions. Since I'm also like working on Kepler tool, how can I integrate this tool to the Amadeus platform? So first my question is like based on my calculations, like when I increase the time range, like comparison to 1 hour, 2 hour comparison, I take correlation ratios, and I compare to 1 hour, let's say 24 hours. Model estimation is actually a bit diverse, so they're not accurate. I thought it's probably because of the sudden spikes or downs occurred in that 1 day area. So do you have any plan to handle less spikes or downs on the machine learning model for have a like more concrete?
So where are you running Kepler? And where are you running?
On the VM.
On the VM. Is it like a public cloud or your like company servers? Is it private cloud or public cloud?
It's like just I'm using the pre-generated Kepler sort dashboard available.
And what happens is that at a given point of time you have some spikes in the model.
Yeah.
Yeah, I think you're like still. I haven't run Kepler in production sort of for a full day, so I wouldn't know how to help you with that one. But definitely you can open an issue like in the project and like write whatever you observed. So like this spikes problem and whatever analysis you have made, and then usually they're quite responsive and they will come up with some solution. And maybe there is a bug they haven't noticed yet on the ML. But I know that the ML model has some problems they're still working on.
Awesome. Another question I have.
Sure.
So in the metrics, I saw that you have some metrics for the package, which corresponds to the CPU sockets consumption, and also your metric for the DRAM consumption placed in memory. In our model, we also put in the network consumption. So do you have any like do you plan to generate some other metrics called like network, or is it also consist in the package metric?
Yeah, I think CPU and memory consumption are like, I think I read some papers some while ago in which they say like they've proved that CPU and memory consumption are like 90% of the emissions. That's why maybe they haven't chosen yet to use networking metrics. But I don't know if like I don't think it's like relative short-term plan to introduce these metrics. But this also can be tracked in a feature request at the repo.
I was just curious to hear more. Yeah, what are the types where requests are on? So for what I'm hearing, still not production ready. You mentioned it. What is the more time frame you have that recommended? Use it, but to also feel confident that the software is going.
Yeah, so that's a very good question, and I don't know. So like the first question is what kind of issue we had. So basically, we tried an AWS EKS cluster with a single node, and then we tried to see what kind of metrics would come up, and then for some reason there were at first like all the metrics would come as zero, and then we had another installation in which they solved this problem, but then like all the pods were coming with similar like numbers. So like if all the containers were using the same amount of electricity and looked seemed like an error or a bug. And we're trying to still understand how is that. Maybe one of the reasons is that we haven't load tested the server. So we have just tried the installation and then check the metrics, but we haven't run a real container doing something, right? Like, so it's just trying to see the metrics for a given Kepler exporter and then some cube system pods. So that's maybe a reason. And I know that there were some problems with different C group, V1 and V2, because under the hood it's using C groups. I know that they also fixed that, but yeah, like when this will be production ready for AWS really, I think, depends on the community. So on how much effort we put into testing these, because yeah, they are mainly they mainly work with OpenShift. So I think for OpenShift they're much more ready, and yeah, like the more we test it, the more it will be production ready. Yeah, time. It's the last one. Yeah.
Maybe like a more general question, but in my experience, like companies care about money most.
Definitely.
So money cost, like cloud cost, should very, very strongly correlate with the environment impact. So why do you think it makes sense to measure it on such a fine-grained level as like Kepler is doing, instead of just using the cost of the cloud resources?
Yeah. So you could say that reducing costs would also reduce the carbon footprint or like utilization, right? But it's not that simple. So I haven't fully understood why, but I guess you can run into some cases in which, like, even if you try to reduce cost, you still would use more or less same amount of CO2. But I don't have an example on top of my tongue. Maybe you, Max, have.
Yeah.
I remember this question was answered like a lot of times, but I don't remember the answer. Oh.
So the question was like if it's how cost and carbon footprint practically correlates, and why you don't optimize just for the costs and only for carbon. So the thing is, cost optimization is actually quite static and quite simple, right? The costs doesn't vary drastically over the day. The costs are very stable. You know them, that they're, for example, in Ireland is like a cent cheaper than Frankfurt, and that it's in other regions isn't that cheaper. So to optimize in this way is a very good first step. We did some projects where we found out if we cut costs around 15 to 17% over the whole year, we reduce the carbon footprint by almost 60 to 70%. So it does not even correlate. It's like a factor of like 2.5 to 3 times, which is fine, which is cool. But the thing is, it doesn't, it's a case-by-case situation. And practically, or better to say, I believe what would make more sense when you optimize for carbon is to put it into different levels, because cost optimization in cloud infrastructure environments is only infrastructure optimization. Cost optimization in cloud environments is very rarely a software refactoring, right? Most enterprises have done a lift and shift into the cloud. The least companies refactor the whole application to be more flexible, more dynamic, and so on and so forth. They wish to, but the reality is a completely different story. In fact, we see enough people and enough enterprises running one Kubernetes cluster per application because I have some security constraints and whatsoever. So, but there are solutions around it. But again, it's more like a lift and shift. So you could do way more things. And when you come from the sustainability perspective, you directly will hit this perspective and say like, okay, I maybe need to change my whole architecture of my application. This maybe means that I use some different kind of buffers. That maybe means that I should question how highly available should be the application, right? Like in our case, we often go to customers, they're like, oh, it must be super highly available. I'm like, okay, how much highly available? 4 nines would be great. And we're like, mathematically, I cannot promise you this. The cloud provider gives you three nines and a 5, sometimes even less. So it doesn't matter how much you want to distribute it. You do not come more than 3 nines, right? And so looking again from a sustainability perspective makes it way more difficult, way more dynamic. You have a lot of variables in this. If you want to break it down, then you need to consider if today is a good weather, sunny, shiny, a lot of wind going on or not, right? And it will have a change on the actual carbon footprint of your application. And yeah, so it's way more complex. There's some very stupid thoughts about it, like maybe an enterprise architect or a solution architect even should look on the weather forecast when they design the application and consider the weather for a geolocation where they would like to put the application, because maybe it makes sense to put it in another country, for example. So there's a lot of things around it, but it makes it way more complicated than like, oh, this service per gigabyte costs that amount of money. Easy to optimize, but if you want to optimize for carbon, then there's where the engineering challenge, I would say, starts, right? That's where the play child comes out and says, oh, I would like to dig into this one and that I also would like to change, rather than just to turn down the cost. Yeah. Yeah. For the first step, always great. All right. Because of time, we come to the next one, and thanks, Antonio, again.
Super. Yeah, thank you. While we wire up here together with Drew and Satay, I'm super excited and super happy to be allowed to present here today work at Amadeus, which we do around green IT. Maybe a few words to myself. My name is Fritz. I actually studied meteorology in the 90s here in Munich, so I feel very attached to a picture like this one here, which represents the temperature, the average temperature of the years from left to right. And you see a concentration of red lines here on the right side. So that is a quite strong driver for me personally. And yeah, I'm super excited that hopefully we can also work on the solution together. A few words to Amadeus. If you haven't heard of us yet, we are an IT company at the boundary layer between the travel providers. So think of an airline or a hotel group or a railway company. The travel sellers, think of a travel agency or more modern, a website where you search something, and the travel buyers, that's literally you and me who travel. We're in between. We have the data. We will get the request. We will compute the possibilities, how you can travel from A to B and do the IT behind. There's many airlines connected and so on. That are the business figures. I more want to draw your attention to what it translates to technically. So currently we are in a phase where we transition from on-prem to cloud. The on-prem size is something like 17,000, 18,000 physical servers. You can imagine that it will translate into something of a comparable size in cloud. It's a data center located in Erding, not so far from here. The consumption is around 6 megawatts. So this will be something like 50 gigawatt hours per year. It's 2 billion search requests per day. That's an order of magnitude that you will also find with eBay or maybe Google search. And that's actually quite a lot for the fact that nobody tends to know us. The other message here of the slide is it's a relevant size. Yeah, it's a block. So I tend to optimize my house at home with light bulbs and fridge and so on. But of course, my household is ridiculous compared to the figures of the company. So it's a relevant activity that we, as engineers, take responsibility for that. Can you switch, please? That is our motto. And of course, we want to make the travel experience better for everybody. I want to focus here on our ESG ambitions, people, places, and planet. And here on the following now, focus into the planet part, plus another zoom in. Yeah. I want to concentrate on the things which we really have under our control. So scope 1, scope 2, scope 3 was already mentioned this evening. Things which are under control, our control as IT engineers. Can you switch? Yeah. So this is a roadmap on our company activity, which we drive. So we start with education, driving a change. Here we work together with Climate Fresk. I just previously heard the discussion, how big is actually the impact of the network? So that is actually one part of the Climate Fresk. So IT, you might know, is around 4%. 1/4 of which, so 1% out of the global emissions actually comes from the network. So internetwork and all the network that we run here. With the education to engage our engineering community that usually works by itself. It's easy to find engagement on the topic. Measurement as a pre-requirement in order to do anything was already as well mentioned. And here we work with the SCI, which we also have seen already before. So I'll zoom into the SCI to remind everybody. The software carbon intensity formula, it's E multiplied by I. E is the energy that we consume. The less, the better, of course. I is how it was produced. So do we have dirty energy? Do we have clean energy? The M is what we used in to build the computers. The less hardware we need, the better, of course. Sorry. And the R is the unit cost. So we divide by unit cost. You might imagine a passenger here. Yeah. So on the ticket of the passenger, there might be an information. If you fly from A to B, you emit this much CO2 for the flight. But we should actually add also, you also emit this much CO2 because of the electric processing of the ticket. Okay, so where did we start from at Amadeus? So we need a way to monitor the consumption. Otherwise, we cannot formulate objectives, and we actually don't know where we stand. And we want to be carbon neutral by 25. And together with the IATA, we want to be net zero by 2050. So, of course, there is still a lot of work in order to achieve this. And we didn't find ready products off the shelf that we could use. So actually, we don't want to invent too much ourselves. We want to use industry best practices where we can, but we didn't find something which was really exactly matching our need. Okay. Here to the formation of the team. So we have a virtual team called Software Carbon Footprint Team, and it evolved from several teams here represented with X and Y that all started actually driven by green mindsets and awareness to start to work on the topic. How can we improve? The Green Software Foundation played a strong role with the SCI. These people connected in the company, and that gave birth to a virtual team, which is here. So here is also Satai in person and Chu in person. Very welcome. And we are very happy that it's a diverse team with young people, with senior people, and they're actually located in different geographic areas and also different parts of the organization.
So
wait a second. Okay.
Okay, so I would like to talk about our Cloud Carbon MVP architecture. So basically, we have some running apps in the cloud. So we first need to gather this data. At the end, we have to calculate the carbon emissions. So we just gather data and measure the resource usage, the CPU usage, the memory usage, and the network usage, of course. And then we gather them on also the open constants, such as like the power usage effectiveness, like the location of the system, because the carbon intensity also connected to that location thing. Also some electricity ratios and so on. And then we need to we calculate the electricity consumption based off the CCF methodology. And then in the end, we show the dashboard as a carbon emissions of that according to that electricity consumption. So looks a bit maybe like complex, but I would like to show you the tool itself now. So this is the cloud carbon MP that we just talked about in the previous slide. So I would like to show you the dashboard info. We have some kind of like small panel of that. We can add some purposes of the dashboard, some point of contact to the related and issues appear on the dashboard and so on. And you can choose your apps. So the grant level could be the app level or the platform as a service level, or the namespace level. So in that app window, I would like to choose an app which uses a persistent storage actually. Yep. Basically, it needs some time for the gathering information. Okay, so I would like to increase the time range because 1 hour is not really like a lot. Let's say like last 24 hours. Okay, it could be like some time-consuming stuff plus the network delay.
The calculations are easiest, right? Or
Yes,
you have some tooling. It's all.
it's built in the dashboard actually. It's built in on the when you press edit, you can basically see the dashboard.
Pre-compute. Yeah, fancy this. Yeah, all the time.
It's not pre-recorded. This is really live data that is really run system.
But if you configure procedures for recording rules, then it's like pre-calculate the time series when injecting the metrics and not when querying. Right?
So, okay, I changed the time range to the 3 hours because like time consuming when compared to 24 hours. So basically you can see all the CPU utilization and the other CPU metrics belong to that application, which is the 3 box that I just choose. You can also see the CPU carbon emissions based on that CPU energy consumption actually. Plus, what we talk about is the memory energy consumption. Let's just open all of them. Yep. Okay, let's start from bottom now. So we have the panel for the embodied emissions, as you just see, and on the top of them, you can see the persistent storage. You can see the energy consumption derived from the persistent storage of that application. So we basically like 4 different options: storage itself, the power consumption, also the energy consumption. That's things really correlated, and the CPU emissions. All these 4 different metrics. When we come to the network, you can see the network bandwidth and some memory-related metrics, as you just seen. And in the end, we aggregate all the metrics that we have. All those 4 different metrics end up with that dashboard, which shows the energy consumption, the carbon emissions, and the total CO2 over range period. This is just shown like that. That's basically our like cloud to carbon MP for now. Thank you.
Thanks a lot. And I'm happy that the live demo worked. So what we've seen is a use case of, I move here, of a requirement to monitor. Yeah, we were able to see the live data and to see what the system is currently doing and translate this into carbon emissions and into electricity consumption. We identified 2 more use cases to analyze. So imagine, for example, the engineering team has a choice to implement an algorithm which uses more CPU, but it saves memory, or the other way around. And the engineering team, of course, needs to know in advance which of the 2 choices is actually better. So that is the idea with analysis. Reporting is a third one. We had a discussion kicking off, does FinOps, I want to call it FinOps, the cost question, yeah. Do we actually reach our target? Are we on track for the net zero in 2050? Do we need to do more? So that would be reporting. And to give a bit more of the detail on how it's intended to work. So we've seen here the telemetry data that gets translated into CO2 and electricity consumption. We've just seen the monitoring case. Can you go next? Yeah. So the analysis part will differ from the monitoring part, that it's interactive, yeah, that it sends a query, that you can simulate things, but it still will be very detailed, and typically it will be an engineer who is using it. And the last one, trend data, we expect we can aggregate a lot, but we need to store over a long period of time. Maybe we have to report over 5 years, we are on track or we are not. Yeah, and you see here, that's a screenshot actually from the FinOps system. It has a tiny euro here instead of CO2 kilograms. We want to introduce the additional metric of displaying CO2. You know, as a public listed company, we are obliged to report our CO2 emissions in our quarterly reports. Of course, this data need to come from somewhere. Okay. So back to the roadmap. We cycled a lot here now on the measure. We've seen an MVP on how we can implement a measurement. Yeah, now we can go to what we actually want, minimize and optimize. Ooh.
Hello, everyone. I'm Xu from Amadeus Green IT team. Well, as you've already seen tonight, mostly the talk, including our company and the reply, is on the measurement itself. But very interestingly, that's the next question gonna be, okay, how, as engineers, what can we do? How can we minimize the carbon footprint we generate in our software footprint? Software stacks. And very funny thing is that when Max was replying the question regarding to the cost analysis, he mentioned something with, okay, then where or when like we can run our like applications or jobs. Funny thing is that is actually a nice topic that I will present to you. Okay, very intuitively, our proposal that we're exploring in Amadeus is how we can minimize our carbon footprint in the scheduled jobs. So as an organization gets bigger, you have more workflows, and those workflows get automated. And there is a considerable amount of scheduled workloads basically in the scheduling tools you use. But then for many of those workloads, developers probably don't really care when those jobs are being ran, as long as those jobs are processed on the specific date. So what they don't do is they don't even specify time range, or even if they do, those time range can be very random, and a lot of times there is no good reason for such setting at all. And the same situation happens in Amadeus as well. In our scheduling tools, when the calendar basically is when the calendar hits that day, say like, okay, the next day there's a 500 jobs going to be run on Wednesday, tomorrow, sorry, yeah, on Wednesday. So what happened would be all these jobs will be processed right after midnight. But then, as you already know, maybe from throughout the day, the carbon intensity can vary greatly depending on the time. So as you can see the map, when we have more clean energy like solar or wind, then naturally you would have like, let me see this, decreased the carbon intensity. And for midnight, you don't have those resources. So you actually have one of the worst carbon intensity in a day. Then if all your jobs are being processed right after midnight, then, well, it's not very environment friendly, basically. And so what we want is actually, what if we just change dynamically when and where to run those jobs, especially for those non-critical timing sensitive jobs, then we can actually potentially decrease our carbon footprint significantly, actually. So we, with the same workloads, same amount of electricity consumption, we've already done better job. Now I show you a very quick overview on our design idea. So basically, we would take the open source carbon intensity, like Green Software Foundation. We take those hourly updated carbon intensity, and then we take the data to set a 7-day average baseline. With that, we take into consideration parameters into consideration, including intended start time, end time, workload priority, duration, and where you want to run your job. And then basically, the optimizer would pop out an optimized 1-hour time interval. For our case, we are under the assumption that most of the regular jobs finish within 1 hour. Only with very few exceptions. And then once you have this optimized time, the optimizer will push the setting to corresponding scheduling tools. As you can see, for our case, we are using 4 different scheduling tools in Amadeus, with Control M as the biggest one. And then the optimizer will just repeat such check and update those jobs on a daily basis. And then additionally, if a developer does not want the job to be changed dynamically for any kind of reason, okay, but if there's still a certain freedom with the time setting, then the developer can just use the optimizer tool to get a suggested time range and set the timing. This is actually even better than they set time randomly already, because as you can see from the graph earlier, most of the times you have the optimized time interval is between like morning to noon. So if they can just change that timing, it can probably decrease the carbon footprint for some amount. And a sneak peek to the optimizer box itself. As you can see here, you provide the location, intended start time, end time, priority, and then you get the best optimized time interval back. And for our case, since we're all of our servers are still based in Erding, so you can see the location provided here is Germany. But then if you look closely, some of you may wonder, okay, where is the degree thing comes from? I didn't talk about it. As I just mentioned before, so most of the best time is always between morning to noon. Then what if you have hundreds or even thousands of jobs in your company, in your organization? It's probably not a good idea to schedule all those jobs in the same like time slot, especially if you have like other critical like a CPU intensive jobs are also using the same resource, right? So what this degree option, it's basically enables you to offset the time interval. So instead of always giving the scheduler the best one, it can give it, okay, the second one or the third one. And by doing this, you won't have such like crowded setting. And that's all I think. Thank you. And questions?
Presented the part of so you have some calculation of CO2 emissions by the watt-hour or the electricity consumption. To consider for this also this different energy mixes during the day, or do you just use them?
Satay, correct me if I'm right or wrong. In the MVP, which we have shared, we are, to my knowledge, using a constant. We are not yet at the level where we take the current bill. But of course, we would like to have the current grid. Yeah, it makes a difference if there's maybe a lot of sunshine right now,
Because otherwise I have to show us the 24 hours. And so I would have expected a greater discrepancy between the energy consumption and this, depending on the power generation in the daytime. Maybe a second question. So, for example, what I was thinking about, and we discussed some of this. Answer the question from my point of view. SSD are totally less or more efficient than spinning disks.
Yeah.
Because spinning disks need to rotate the disk all the time. Do you consider this, or also use an average for storage?
No, in this case, we are using data, third-party provided data. I think actually it's from the Green Software Foundation, what we are using, right? So we definitely do not have the capabilities to measure this data. So we use somebody else's data. I'm not sure about the granularity if we would now be able to compare different vendors, but we use types of hardware, yes. And of course, I mean, it gets the harder the more granular it is. So you just said, do we take the grid current situation? Actually, I would imagine probably when done properly, yeah, when done thoroughly, it would be even more difficult, because we actually cannot just take the average grid from the moment, but we actually would need to think about, if we now put, I don't know, a megawatt of additional electricity on the grid, then the sun will not start to shine more, yeah, to give us this extra megawatt, but maybe a gas plant will kick in, and actually we are not as green as the average with this additional 1 megawatt. So it can become complicated. The MVP, for very sure, doesn't consider all this.
Just to mention, the smallest granularity level is namespace for now, not the pod level as in the kernel.
Actually have Kepler up here. Upper left. Yes, please.
Just one thing, like for these monitoring tools, like using Grafana and all this. So do you guys also measure how clean these products are? Like how much carbon they consume when you continuously monitor something, and pass the data back and forth and process it, and especially the aggregation itself, because that is also like high CPU intensive.
I mean, how much do we pollute by measuring the pollution?
Yeah, exactly. Yeah.
I would very much hope that one of the applications which was on the list would be our monitoring environment. And of course, we have to pay the bill for the monitoring environment to the cloud provider. And we also have to consider the pollution that it produces. Yeah, of course. Yeah. So that also takes this generating the visibility, of course, also takes and produces an impact.
Yeah, of course, when we use these tools like this, because they also like consume a lot, data breaks and this Grafana. So these tools don't come for like free, right? Because they also consume a lot of disk, CPU, memory, blah blah blah.
Storing data, processing the data is CPU intensive, it's storage intensive, and it definitely has a footprint. Yeah. Yeah. So I don't have numbers in my head how it compares. I know from the operational side that in general the management metadata is a significant part of the workload itself, and it can even supersede actually the real production payload. Yeah. Mm-hmm. So the question is very justified, and we need to keep an eye on it. My statement is now not on precisely the green metrics, yeah, to measure these and to have Grafana running. But if you take all the logs and everything together, that's a significant pile of hard drives. Yeah.
Because like if you monitor and take some decision, right, like then it could make sense. Like if you monitor and then you automatically reduce as a result of monitoring, you achieve some like you achieve less carbon emissions, or you offset something, for example, from the overall thing that you are monitoring. Then you say, okay, I killed this many people, but I saved this many people. That makes sense. But if you are like killing and not saving anything, like you're doing more emissions, then reducing the emissions in the end, then in the end, it's like you are not saving the environment rather than polluting it. So
if you don't,
yeah, so this is my thing is like if you just keep measuring, but
if you don't measure, we will never know. Yeah. So please.
Do you have any research or analysis how much you could eventually save? The question basically becomes like, how bad are we at this point in time, and is it worth it to?
Right now, like for example, the scheduler, we don't have a specific number right now. But that's the goal, that we will have that comparison, say like every month, how much, like what's the percentage that we reduced. But this because this is still under exploring, because we have hundreds of applications. I basically have to figure out, okay, which applications I can touch, and within which applications, what are the jobs that I can touch, like say that maybe some reporting jobs, testing jobs, just like data transferring jobs that I can touch, and the rest of them, oh, okay, they're too critical, and without, just don't want to risk the business side of like impact, and maybe like let's not touch them. But still, because we have a great number of scheduled work in Amadeus, and we already observed, like my manager have observed them from decades. They are always like just put on the day, and then like for example Control M just run them right after midnight, just and then the graph I showed you guys, as you already know, okay, midnight is always the worst. So if we can just change that part, it's definitely gonna be a big reduce. Yeah.
I love the question. Of course, the price differs over the day, and there was the question, does actually cost saving automatically lead to less resource consumption? And I would actually put this now as an example of where it doesn't. Because typically, when you look at the renewable energy that's in the grid, then, okay, I mostly look at the German grid, yeah. Then there's usually a lot of solar power over the day, and at night you maybe have wind, but if you don't have wind, then actually at night it's not looking so great. If you look at the price curve, then the price curve is the highest in the morning and in the evening, because that's where the ratio between the consumption and the production is, so to say, the worst. At night, it's actually usually quite low, the price. But the carbon intensity of the electricity at night is high. So here, the cost saving or the FinOps response would be, yeah, like in the old days with Nachtspeicheröfen. Maybe the older German semesters still know these. Yeah, let's maximize the electricity consumption at night in order to save cost. But from environmental point of view, it's actually not good.
Yes, but there's one issue with this argumentation, because usually I would save the cost looking at my Amazon bill, and Amazon does not have different prices over the day. So if I order an EC2 instance of a certain type, it is $1 an hour, and it is constant over the day. And so this, I don't know what contract Amazon does have with the power supplier, but they do not offer us the power exchange prices.
Yeah.
We've still been talking about 17K servers in getting. I guess you measure your electricity consumption.
Yeah, of course we measure our electricity consumption. Yeah. It's yeah, the consumption is usually quite flat actually, because it's again, mostly we are business, we are commercial business. We are, of course, to start with, we are cost driven. Yeah. It's quite complicated to build the infrastructure, to build this elasticity, to bring the servers up and down. So maybe it's relatively easy to stop a pod. Yeah, you deschedule it, and then if you live in the cloud world, in the cloud mindset, this pod has disappeared, or the resources are freed up. If it is running on-prem, there's still a running computer, which is still consuming electricity. It's a little bit less because the CPU isn't that much loaded, but it's actually most of the consumption is still there. To really turn off the computer, to fully save it like it looks in cloud, is hard. Yeah, it takes a lot of infrastructure. It takes a lot of engineering to really do this, and that. Okay, I'm not a cloud provider, so I do not know it, but I guess that when Amazon designs their prices, they also take this into consideration. So I'm not so sure they really turn off the computers when it's descheduled, and when you run your pods in Amazon or whoever, you actually also pay for this part of the inefficiency.
Sell it then as a spot instance, for example.
Maybe they sell it differently. Yeah.
Maybe one more question. Yeah. So on the first slide, you showed the DC power consumption, not the AC.
Sorry, data center. That was intended to say data center. Yeah. So it's sorry, I didn't bring a picture with me. We have a nice building where all this is inside, and
yeah. So because I was thinking there was in the data center design, there were some considerations a couple of years ago to have a DC power supply throughout the data center. Yeah. Because the transformators in each rack are less efficient if you do it on a large scale. And there were also such things like hot ale and cold ale and a lot of green stuff, which you lose, I think, if you go to the cloud, because then you do not have any influence on those stuff anymore.
I'm now for the data center not sure on the DC and the AC parts. I'm very sure on the hot ale and cold ales. So that is a great way to improve the PoE of a data center. I would expect the cloud providers know this as well, and they also arrange their racks in a sensitive way and provide their power in a modern way. Actually, the cloud PoEs, the newly built data centers are quite efficient. Yeah, so when the tendency is, the newer the building, the newer the data center, the better it is optimized. Like when you get a fridge, yeah, you also have a tendency that the newer the fridge, the more modern it is. There was still question.
I will be on side because I think Lux also wanted to ask questions. Number one was there's this other group called the Greenberg Triangle, which is also developing, it's also doing their own analysis. I don't know if they're somehow working with the Green Software Foundation, but the Green Triangle has also developed the models around data centers. And one of the conclusions they have is about rating data centers on where are the sources of energy and any offset the data center itself tries to invest on, right? Because like you said, there's a lot of challenges. So one of the solutions is Amadeus could invest on real offsetting, especially when in Germany, when the country as a whole hasn't really invested that much in investment, right? You're tied to the environment, the energy providers, you have. So one is if that's kind of something that would help a company like Amadeus improve the numbers, or is that something you've considered, or it's already been considered there that you never spoke about offsets? And the other concise question was, this is an experiment, you said it's a costly experiment. How do you talk with your business stakeholders about it? Right? I can tell you, it sounds like you're way ahead of many other companies your size for what I've been a bit exposed to. So how do you manage that conversation with stakeholders? Like, hey, this is worth investing on. It's an experiment. You probably didn't promise any results yet. So how did you, or where did it came the motivation to invest in this project at Amadeus?
Okay, sorry. It was two questions.
Offsetting.
The offsetting. Thanks a lot for this question. So when I showed the roadmap, I was showing the engage and the drive change bit and the climate fresk. We also have this picture with the hands and the hearts is a community of people, and we discussed this question of offsetting a lot. Amadeus is actually doing that. So, for example, the electricity contract that the data center is on is actually a renewable electricity contract, like you maybe also have it for your private household. Yeah. And the discussion that kicked off was, of course, great, we're done. Yeah. Of course, we are not. Yeah. So we have decided not now to look at the offsetted or not offsetted CO2, because it basically kills the discussion. Yeah. After that, you no longer can really argue. Is it still worth doing, so to say? Yeah. So the unit that doesn't lie, so to say, is the electricity consumed. It's very clear that electricity that is not consumed does not need to be produced, and you do not have this argumental problem. Having said so, of course, it's better offset. Of course, it's better to give the market an incentive to invest into green electricity production rather than not doing it. Yeah, so or to fund different projects which are offsetting. So this is clearly better than not doing something, but it doesn't solve the problem, and it's dangerous to have it in the discussion. Yeah, so that is a little bit how the discussion goes internally, where to go. The other question was, how is it perceived by the customers?
So this presentation and the fact that Amadeus has invested some amount of time and effort on exploring the possibilities is an investment, right? And it feels like not so many companies are doing that investment. So I'm kind of curious, how did your team or how did you got to this place inside Amadeus that your stakeholders, the company, either was convinced, maybe by somebody internally, or from the top down, the desire to make this exploration?
Both. I would actually link it also to the customer question. So I'm happy that the travel industry and the IATA is taking a quite bold target of wanting to be carbon neutral or net zero in 2050, which, if you look at the numbers, is really a huge challenge. Yeah, a lot needs to happen until we are there. And together with the industry, so as Amadeus, we are part of this travel industry rather than the IT industry, actually. We don't now really run into many obstacles with pushing a green idea, because we feel also embedded into an industry that is supporting it, plus the airlines themselves. They also know what is needed, yeah, for the climate change, and they support it. I also personally believe in it because it's an innovative industry. It's relatively expensive, so if somebody has the money to pay these bills, then it's probably airline travel. It has always been more on the expensive side of traveling rather than the cheap ones. So I think it makes sense for this industry to pick up that challenge. So coming back to our management, coming to our customers, I think we are all in this phase where we understood we have to do something. We recognize how big the task is, and we try to get started in a good way. Yeah.
Just
sorry, he was 1 second. And we have to stop at some stage probably. So last question, and then we will be with the drinks.
I don't know. You're in the travel business, connected to the travel business. On the certificate, so you have the number of say how much carbon dioxide how you reduce, and management maybe it's sorted that out. Like these rates go out for business. Travel business is a big thing, and they want to have the number. This. Yes. And they wish to have it. So it's not just for greening needs, it's also something that comes daily business in future. Not, I think it's
Thanks for reminding. Actually, quite a bit of this is not necessarily management driven or not. It's actually legal obligations, the reporting of the CO2 consumption as a public listed company. The European Parliament or Commission has just decided a minimum amount of, for example, sustainable aviation fuels per time. So the politics also set the market into a condition where you better speed up. Yeah.
Here and you can produce it and think about this and then you use, because this will happen in many companies. They need it. The most speech, so it will come.
So thank you a lot for allowing these many questions, and we'll later be at the drinks and the pizza to answer more.